Hello guys, in this video we are going to discuss about the per unit system. What is per unit value, why we use these per unit quantities, what are the applications or uses of per unit representation, what are the requirements for calculations and the formulas related for that calculation. First of all, about the per unit system. For the calculation purpose, the power system engineers used this per unit system to express the different quantities like current, voltage, impedance, kVA in terms of multiple of base quantities or decimal fractions. By using the per unit system, the complicated network is converted into a simple one. Then what is per unit value? The per unit value is nothing but the ratio of actual value to the base value. Why we use this per unit quantities? Instead of using kilowatts, kilovolt ampere, megawatts, megavolt ampere, we use per unit quantities in power system analysis because it makes the calculation simple and easy. The values in per unit are more informative. What are the application or use of per unit representation? The per unit representation are mainly used in load flow studies, fault analysis. Then what are the requirements for the calculation? Generally, power system network consists of four quantities: voltage, current, kilovolt ampere, impedance. In the numerical, we usually given with two quantities: kilovolt ampere, kilovoltage. By using both of these, we need to determine the base values of current and impedance. After that, we need to determine the per unit value of impedance. Then, the formulas related for calculation. For single phase transmission, for three phase transmission. In single phase transmission, we consider the voltage between line to neutral. In three phase transmission, we consider the voltage between line to line. For base current, we know that power is equal to VI. We need I, so I is equal to P by V. Here P is kVA by P is equal to kV. So from these calculation we determine this expression: IB is equal to base kVA for single phase by base voltage kilovolt line to neutral. For base impedance, we know that Z is equal to, that is I, impedance is equal to voltage by current. Here V is equal to kV, base kV by I. We already determined this I. This I is nothing but base current. By putting this IB here, we get this expression. So therefore ZB is equal to base kV line to neutral whole square by base MVA for single phase. Similarly, for base current in three phase transmission is determined likewise like this. We know that P is equal to VI. We need I, so I is equal to P by V, where P is equal to kVA for three phase and the V is equal to kV. For three phase, we need to remember this: V line to neutral is equal to V line to line by root 3. Base impedance. For base impedance, we determine through this formula Z is equal to V by I. By putting the base current here, we determine this expression. After determining these both values, we need to determine the per unit quantity of impedance. We already know per unit value is nothing but actual value by base value. From the above derivation, we got ZA. ZA is nothing but actual impedance by we determine the ZB. ZB is nothing but base impedance. For per unit quantity of impedance, that is ZPU is equal to ZA by ZB. By putting this ZB here, we got ZPU is equal to ZA into base MA by base KV whole square.